Genaille Lucas rulers are similar to Napier's bones in that you can use them to calculate the result of simple multiplications. But unlike Napier's bones, you don't have to remember the result of a carry from column to column in your head. You can read all the results from the ruler in and of itself. Also, there's a different form of ruler that performs division as well as multiplication. We'll illustrate how the rulers work with a simple multiplication. We'll determine the result of something obvious, 501 multiplied by 1 using the ruler. So we start here with all the rulers. We're going to multiply 501. So we lay out all the rulers according to numbers at the top. 5, 0, and 1. And we'll need another ruler called the index for any possible carry-out digits for a fourth digit. We now have the proper digits. The index 5, 0, and 1. We're multiplying 501 by 1. I'm speed posting the first of the operands, the 501, up on the wall. For the second operand, the 1, with the rows in the column to the right. So the 1, when we follow the arrows, is the first result. To get the next result, follow that arrow, and we get 0. Follow the next arrow, and we get 5. Or in other words, 501 times 1 is 501. A slightly more challenging number, 501 times 3, which is 1503, and shortly illustrate how it works, how we determine the value of the ruler. We're going to be multiplying by 3, so we count down 1, 2, 3. And as was the case before, we start reading numbers off. 3, 0, 5, 1. The final number that we're going to multiply out is 256 times by 8, which yields the value of 2048. So now we have the rulers for 256 posted on the wall. We've got the ruler for the 2, the ruler for the 5, the ruler for the 6, and plus the index posted on the wall. Multiply by 8, count down 8 rows. 1, 2, 3, 4, 5, 6, 7, and 8. Read off the result from the top value of the row, and that's an 8. We then follow the arrow to the next ruler in the next column, and we get a 4. We follow the arrow to the next column, and that yields a 0. Following the arrow to the final column, the index column, we get a 2. Now with the rulers, you might ask, why are the values sequential, increasing by 1? See the index increasing by 1? We see one of the rulers, the successive values increasing by 1. We see the answer to that when we perform some multiplications and look at the carry-out value as you perform multiplications 2 times by different values. 2 times 2 is 4, carry out 0. 2 times 3, the result, of course, is 6 of a carry out of 0. 2 times 4, the result is 8, carry out of 0. 2 times 5, and the result is 10. Now we have a carry out of 1. The carry out has increased by 1. That illustrates an example of why the numbers successively increase and increase by 1. Just to show some other values to pound home the point, we've got 3 multiplied by successive values. 3 times 2, 6, carry out of 0. 3 times 3 is 9. Carry out of 0. So carry out still 0. 3 times the next value is 12. Now the carry out's increased by 1 to 1. Three times 6, 18. Carry out of 1. Go to larger values beyond 1 just to make sure you're convinced. 3 times 7, 21. The carry out is 2. So it's increased from 0 to 1 to 2. And in case you missed it, what I said, it goes 0, 1, 1, 2. And that's why the ruler values and the index value successively increase by 1. Although there's many resources that indicate how the rulers work, there aren't many resources that indicate how they're designed. Why are they designed the way they do? So now you've got knowledge that no one else has on the internet. Good for you.